Okay, in this presentation we're going to look at a conditional probability question. A large bin contains three different types of batteries. The probability that a type 1 battery will contain over 100 hours, that's something that's going to be important, is 0.7. And the corresponding probabilities for type 2 and type 3, okay, so we got three types of batteries are 0.4, 0.4 and 0.3. So let's just keep collecting up all the information that we have. Okay. Now, suppose that 20% of the batteries in the bin are of type 1, 30% are of type 2, and the remaining are of type 3. Now, immediately we'll sort of notice that that is 50%. Okay. So what is the probability that a randomly chosen battery will give more than 100 hours? And the second question is, given that a battery has lasted over 100 hours, what is the probability that it is a type 1 battery? So hopefully you'll be sort of used to these sort of questions now. But essentially what I'm going to do is just sort of be a bit more advanced in terms of notation, okay? Now, this is an important thing to do at the start of each question. Just sort of write something out, what A means and what B is, or what your events are, okay? So BI is the event that a battery is of type I, where I is 1, 2, and 3. Okay, so B1, B2, B3. Okay, and define A as the event that a battery lasts over 100 hours. So you don't really have to go with A. You can go with H for 100 there if you want. But anyway, that's not important. Okay. Now, so probability of A is the probability of A given BI times BI. So this is the total probability rule, okay? Really, this is something very similar to what I've done before, okay? You can actually equally write it as something like this. A union BI, okay, or have that as a preceding step. But essentially what I'm doing there is just sort of being a bit more advanced in my notation, that's all, okay? So essentially it's just for each of the three batteries, we just write out this expression here, the probability of A given BI times BI, probability of BI, okay? So here it's for battery 1, here it's for battery 2, and here it is for battery 3, okay? Now, we are pretty much given all of the information here. So this is, here we have the probability of up here, 0.7, I'll just go here to the conditional probabilities. So the conditional probabilities are here, 0.7, 0.4, 0.3, and the breakdown, the composition of the batteries is 20%, 30%, and 50% of type 1, type 2, type 3 respectively. Okay, so conditional probabilities here, 0.7 times 0.2 plus 0.4 times 30%, 0.3, and then 0.3 times 0.15. Okay, so there we have it there. So yeah, that's the conditional probabilities there, and when we add that up, it should compute that up and tot that up, that should be 0.41. So part B is on the next page. The question is, let's go back up here to the question. Given that a battery lasts over 100 hours, the probability of given A, given that it lasts over 100 hours, what is the conditional probability that it is a type 1 battery? What is it? Probability of B1 given A. Okay? So this is the conditional probability rule again, okay? And you might notice that this is something called the Bayes theorem is in there. Okay? But so probability of B1 given A can be written as probability of B1 and A all over the probability of A, okay? That is equal to the probability of A given B1 times probability of B1 all over PA, okay, probability of A, which we know before. This is actually something we've worked out in part A, this part here, sorry, meant to highlight that. Okay. 0.7 times 0.2, that should be 0.14. 0.14 divided by 0.41, that gives us an answer of 0.34. 34%, 0.34. Okay, we'll leave it there.